Do you think it's even possible to create end-to-end MLOps? Do you think it's even possible to create end-to-end MLOps demo in Databricks with just 2 lines of code? Yes, with just 2 lines of code. Well, you never know. Then, let's go. Hello everyone, this is MG. Hope you're doing wonderful and welcome to another video. Well, recently Databricks announced some very cool end-to-end demos that include even MLOps. I gave it a try. It's pretty easy to implement, and of course that's a great way to learn end-to-end MLOps in action in Databricks, and also as a tool to start expand it for our own MLOps projects. So I want to provide you a quick overview of how you can implement it, and then deep dive to each step of the demo to understand what tools and capabilities are being leveraged and how end-to-end these are tied together to fully understand those steps, from all the way training your model, deploying them, retraining them, and of course having some specific assessment in place to move our models from one environment to another all the way to production. Then let's check it out. Before we start, make sure you subscribe and hit the bell icon so you will get notified for the next video. Thank you. Alright, let's check out this new thing called demos for Databricks. If you just simply go db or Databricks dbdemos.ai, here's some recently shared demos ready to be implemented in your Databricks Lakehouse architecture. And of course, come here, check this out. If you're a data scientist, data engineer, like there are too many different variety of different type of demos you can implement based on your specific requirements or based on what you're going to learn. For example, if you want to focus on Unity catalog, delta sharing, data warehousing, data science, these are the demos already available. And of course, the one that we're going to emphasize today and give it a try is MLOps, end-to-end pipeline, or MLOps, to automate your model deployment with MLFlow, Webhook, and repo end-to-end. So let's start with, okay, how can I implement this? Just simply you need to install DB demos, and then you need to import this demo and install the MLOps end-to-end. So I already had my Databricks workspace, and as you can see, I did the same thing. I installed DB demos, and then I was able to implement the MLOps end-to-end from all those demos that is already available there. So what happens after? I ran it actually 2 times. That's why I got the error that it's already exists. That's okay. You won't see this if you run it the first time. And when you actually run it for the first time, this is what's going to happen. It will not only give you some code snippets that you can run the demo and see end-to-end, but also it will configure some stuff in your Azure Databricks workspace or Databricks workspace. For example, it will create a job. It actually created a compute cluster for me that I can use it for running the notebooks that comes with the demo. As you can see here, this is not something I created manually. It was actually coming with some demo configurations. I just enabled it. So let's see what happens when you install this. If I come to my workspace, this is the notebook that I have open here, and then I saw that, well, there is a notebook called MLOps end-to-end and some helper functions or init functions that my MLOps demo will call them. So if I open that, you can see the resource has some helper functions for me, and then I have notebook 0 all the way to notebook 7. These are the gradual steps that we will go one by one to see how this demo works and why we need those codes, what are the functionalities, and to sort of understand better this MLOps end-to-end demo, right? So I clicked on the first one to understand how this demo works, and as it says, the cluster has been created for this demo. This is the one I was talking about, and you can see with the same name specified here, I got to know that, well, yeah, the cluster got created with this runtime, with this driver worker, so on and so forth, and it was actually running properly. So if I scroll down, what we're gonna do here in this demo, we're gonna make sure first the data in real scenarios update over time. So we need to make sure that we have a proper data in feature store. We have proper data ingestion. We're gonna make sure that we can use the features for other models or the same model to get retrained. We want to make sure that we have some assessment quality control in place when we move model from one space, one environment to another, let's say staging, how we can apply those tests and get notified if they get approved. Sort of having the governance in place. After checking that, how we're going to deploy the model, how we can understand who actually trained this model, who deployed the model, what data set being used, what feature store or feature table got implemented to be used for monitoring that. So sort of answering questions related to the governance. And then monitoring and retraining. Here as an example, we're gonna see a notebook that again this demo provided how we can automate the process of retraining using AutoML. So here's the architecture of end-to-end how this demo works. We definitely gonna start with some featureization with connected to feature store. If you don't know what is feature store and you don't know the capabilities of feature store in Databricks, I highly recommend you watch the video I created about Databricks feature store. I'm gonna add this to the top right of the screen. Click on it because that's a whole separate topic and I'm not going to explain the details because the video this time is mainly focused on this end-to-end MLOps demo. And then after having the data pre-processed and shipped to feature store, we will grab the features from feature store to build our model. And this demo is actually using AutoML in Databricks, which is not that recent feature, but it's one of the new ones that added that you can do AutoML for classification, regression, and time series forecasting within AutoML, which we're going to use it for this demo. And then as a data scientist, I might run AutoML multiple times for the same project to come up with the best model. So I'm going to assess multiple models, check out which one has the highest accuracy as an example, and I will choose the one that I want and I will request this model to go to staging through MLFlow. And as soon as I request for the model to go to staging through Webhook, it will send a message in my Slack channel, which I'm going to show you, that hey, MG requested this model for going to staging. And then because that webhook is activated, it will automatically run some test codes that I have in another notebook from this demo to check my model performance, to check my model signature, to make sure that there's artifacts logged with my model, there's description enough in my model. So we check them all automatically, and if we all get approved, then the transition request is going to be completed and my model will be in staging. So approved to move to staging. We are here. Then when we have the model, if it's not rejected, if it's going to get rejected, we will get a Slack channel message. A Slack is an example. That can be, let's say, Teams or Telegram or whatever. As long as Webhook is supported, we can send the message there. But as soon as it gets approved, now the model is in the staging environment of MLFlow, so I can do testing, I can do batch prediction, I can do even real-time prediction with having real-time API, and then with having some assessments in place in the staging. The same thing can happen to push the model to production environment, which is not covered specifically in this demo because it's the same behavior and pattern that we did in staging. A test code gonna get run, and upon approval it goes to production, and we got the same message in the Slack channel. And then we can run some predictions over the model that we have deployed and visualize our predictions with some other data from feature store as a dashboard that Databricks also support creating dashboards. And then we can automate or schedule retraining process as well to always update this model, update the predictions, and update this dashboard. So this is what we're going to cover. So let's start. What is the first thing? First, make sure that you run this cell. It will help you to set up some initial configurations and load some helper functions. So I just ran it successfully. And then here, this is the data set that we are exploring for this demo. We are going to actually predict churn for customers. Let's say what is the probability that we will lose a customer as an example. And here's the features related to that customer. Customer ID, gender, partner, citizen, senior citizen, yes or no, tenure, phone service, so on and so forth, and all the way we have churn, yes or no. So that's a classification challenge. So what we're gonna do? Well, we start with feature engineering. This is the place that we're gonna start. So we're gonna go to the next notebook, feature engineering. So let's see what this demo does in feature engineering section that connects to feature store. Again, running the configuration. Here's again the same data that I just talked about. And because I'm a data scientist, I'm more comfortable with pandas, but pandas cannot get distributed like a Spark. So I can use PySpark or actually import pandas PySpark, which the coding experience gonna be like pandas, but on backend it will be distributed as a PySpark API data frame, which is great. So this is what I'm using here. So here the data is already cleaned as demo mentioned. It's just creating some adjusting some column names and values and do some one-hot encoding. That's it. So this is very simple, and dropping some null values and then returning the data. So this is sort of my featureization function. Again, extended for your own project, but here's just an example. Then this is called optional, but I would highly recommend you to do it, to write your features that you generated to the feature store. Again, watch the video I created about Databricks Feature Store. This is the title of this video. But the benefit of Feature Store here, long story short, is first, discoverability. Now, rest of the team can know what features I created, so they can use for their own machine learning use cases, and they're not going to calculate these features again and pay for the cost of compute, resource, and time. Second, when we deploy these models, we should do the same featureization steps for let the model do prediction. But now, because we have stored features in the feature store, the code, transformation, and logic behind the features are also stored with the feature store. So when I call my model and do prediction, and the inputs are coming from feature store will handle those featureization stuff, and it knows what model is expecting as an input to do the prediction. So long story short, two benefits. First, discoverability. Second, facilitating the training featureization and inferencing featureization to get them synchronized. Okay, so I'm going to write the data that I transform to feature store. So I'll call my feature store client and I say that, well, I have a table that I created and I'm gonna store it in the feature store database thing that I created previously. And then, as again I talked about in that video, each feature should have a key, and then you can specify some description about that feature, what it is, how you create it, anything you want. And of course you need to provide the schema of the features as the schema in the feature store. And then that's it. I just write this in the feature store that we specified on the top. And what you will see if I go to my machine learning engineering workspace feature store, well, I just saw that. There you go. That charm features got created. And now I can check this out, and I see that this is the notebook that created this feature. So look at that. You have traceability to go back and see what was the last time this feature got updated by what notebook. Then you can schedule this notebook to update your features, because this feature gonna get changed, and then when the features are updated, we can retrain our models. So that's why it's not scheduled yet, because we didn't do it. And then I can check out the features in that feature table. What is the feature name? If their specific job has been done on the top of this feature or not, what was the last time, what is the type of the feature, so on and so forth. Okay, so let's go back to the notebook that I was doing feature engineering. Let me scroll all the way down. So we wrote the data to the feature store, and now we're gonna train a model. So again, this demo is using AutoML. You can code AutoML in Databricks or use Databricks UI to do AutoML. If I go to experiment here, I can launch AutoML through UI or through code as well. So what will happen when you launch AutoML in Databricks? It will launch your AutoML under MLFlow experiment. That means the MLFlow capabilities, which is tracking, logging, MLFlow model deployment stuff, all of them will come with the outcome of your AutoML. Second, it will give you the code that was being used to generate your best model from AutoML. So if you're gonna get the best model out of AutoML and you wanna know what was the code created that model for you, it will give it to you. Then you can use it for retraining your model with the code that AutoML gives to you, or customize it for any other specific configuration you want. It will also give you explainability based on SHAP, but you have to enable it. By default, it's not enabled. And it will also give you a code that can be used for data exploration, which is called Data Exploration Notebook. So again, this is through how we can do it through UI. You click on experiment. Again, I created another video that I have compared AutoML in Databricks versus AutoML in Azure ML. Check that out. You'll have a better understanding of how you can create AutoML through the UI. So I'm not going to explain that here. But in this demo, it will already launch AutoML for me based on this demo we are grabbing from Databricks. That's why when I ran this code, it says that no AutoML was running, but we already started AutoML for you. So I didn't went through UI and just running this. I saw that, wow, AutoML got launched and is training the model for me. And then it gave me the best model with this performance. I got the accuracy of 82 in validation, within training and testing, which is not bad, but regardless of the metrics, that's just a demo. And then I got to know that AutoML also generated the notebook for building the best model. Let's check it out. So if I go to experiment, you can see that these are all the AutoML experiments that I had before, and this is the one that my code actually ran it. And you can see that I have multiple models got generated by AutoML, and AutoML validation is done. And look at that. I have the notebook that created the best model, and also I have the notebook that explored the data. So if I click on the notebook for the best model, this is what you will see. This AutoML loaded the data for me, did some pre-processing, featureization, like encoding numeric categorical columns, some specific imputation if there's missing values, checking cardinalities, splitting my data to train validation. So what this demo did, actually, if I go back to the notebooks that this demo provided for me, which was here, there you go. So we were in the feature engineering notebook that we launched AutoML, and then this demo is also giving me the AutoML notebook, which is like the same one that I just opened. So if I click on the number second of the notebook that comes with this demo, which is here, it says that build base model with AutoML. And if you check this out, this is sort of the same code that AutoML gave to us. So again, loading the model, and you can see this is the same model that we launched AutoML with. Sorry, load the same data for churn prediction, and then doing the pre-processing and stuff. Again, these are very like cliche. I'm not going to explain that. It's the typical machine learning exploration. Then training my classification model here, XGBoost was the best one. And interestingly, of course, again, AutoML use MLFlow, and it will start logging my stuff with AutoML. That's why you see that with MLFlow scikit-learn, autolog is enabled, so we are logging all this stuff, the metrics and the model by itself when we are running this through AutoML. And interestingly, this notebook will give you the architecture of the model and the performance of, the process of your machine learning training. And if you click on any specific stage of your pipeline, let's say here, it will give you more information, like what are the columns were selected as an example. And that's it. So feature importance, again, I told you that the explanation of what features were the most important one for your model that got trained by default is false because it's computationally expensive. So you have to enable it true to get the feature importance as well. Now, this AutoML notebook will give you some code examples that how you deploy this model. Because for deploying, actually registering this model, because if this is the best model, I'm gonna register it, right? Then if I register this model in MLFlow, then I can, let's say, deploy it for batch or real time. This is the code that you need to do, and actually this code is using these examples to say that, okay, I'm gonna register the first version of the best model coming from AutoML. I give you the name, this is the URI coming from the run ID we have specified on the top, and then we just called MLFlow register with the model URI and model name. That's it. So when I went to the models after, if I go to machine learning models, there you go. I saw that my model got created for the first version. Why you see mine is version 3 stuff? Because I tried retraining to test my retraining code, and I came up with more versions and I deployed them, which I'm gonna come to that shortly. So coming back to the workspace, now we had feature engineering. We stored the features in feature store. Then we launched AutoML. AutoML got trained, and we retrieved the best model from AutoML, which was the model that we just saw for classification. Then we registered the model in MLFlow. Now what we're gonna do as a data scientist, I registered my model, so I think this is the best model, and I'm gonna, let's say, push it to staging, right? I want to request to push my model to staging to get tested before go to production. if I request pushing my model to staging, we should do some testing to make sure that my model is qualified to go for staging. But in order to run that test, I'm not going to call someone that, hey, I'm ready to run the test. No, we're going to automate this. How? With using Webhook. So this is actually the notebook number 3 Webhook setup that we need to set it up. So what is Webhook? Simply, Webhook will call a web URL whenever there is an event. So what is the event here? In case if my data scientist will request a model to go to staging, that's an event. So if that event happen, I'm gonna do 2 things. First, send a message to Slack channel that MG requested a model to go to staging. Second thing that I want to do is run a test code that tests my model's stuff before get approved to go to staging. So 2 things we're gonna do: send a message to Slack channel and then run my test code, which will be a Databricks job. So we can trigger it through Webhook. So let's set it up. What you need to do, again, let me all the way scroll down. By the way, here are some other events that Webhook can support. When a model added to MLFlow registry, you can call an event. When a new version of the model get registered, you can call an event. When there's a transition request, this is actually our demo. That can also do an event. So on and so forth. Let me scroll down. You need to first install Databricks register Webhook, run helper functions, and then here we are creating the Webhook. So it is using some helper functions to run this. That's why the code is very, very simple, because these functions are coming from another helper function. But use this as an example for your own project. So what you need to do for creating a Webhook, you need to first specify, okay, what is the model name that you want to set up some events on it. This is the model. If there's a transition request for this model, I'm gonna enable this Webhook. And then what you're gonna do after? Well, I'm gonna do some testing on this model when it got requested to go to staging, and here's the job that I'm gonna run it. That job is a test notebook, and okay, this is configured by the helper function provided by Databricks demo. But what is that job and how it got created? Again, this demo automatically created for me. But I'm gonna show you what is that job and how it's testing the model before it goes to staging. Okay, and then I create this. This is my Slack URL. You need to grab this Slack URL from your webhook that you have enabled in the Slack that I'm gonna show you how I did it. And then that's it. You can review the webhooks that I created. So I have 2. One of them send a message to Slack channel, and the second one is running my test job. So what is next? What I'm gonna do right now, I have my model and I want to actually do a request to send it to a staging and see if my webhook gonna works or not. So I have the model, again, the same thing like all the notebooks, the helper function stuff, but here we're gonna first, of course, register the best model. But again, I told you that sometimes as data scientist, I have multiple models for the same project. So I want to make sure that I can test them all and figure out which one is the best one to register. So for example, here I'm getting the latest AutoML from an experiment ID given above, and I can see that this is my AutoML run ID, that I had the best model with these metrics that we already discussed about. Now when we have the best model, we can register it. This is a typical MLflow that we talked about multiple times, that how we can register a model with MLflow. We can specify some tags, descriptions, so on and so forth. And then you can even start saying that I want to add some more description to my model. For example, this is the model that do this and that, and you can even specify more description for that specific model version, assuming that this is your version 1, right? Now I want to do that request. As a data scientist, I'm happy with the model that I sort of requested to go to staging. You can do the transition request from UI. You just go to the models, and then you can click on the model that you want and do requests, send it to, let's say, staging as shown here, right? I click on here, drop down menu, go to staging, I write down my comment and click on OK. The request has been created by, for example, this user. But now here with just code or the helper function provided, I can say this is the model, and this is the version specified on the top. I want to push it to staging. And then you can also leave a comment for your request as well. This is the best model with AutoML, and I think we can use it as a baseline. So now what will happen? I should receive in a Slack channel message that MG requested to send the model to staging. Look at that. This is my Slack channel, and as you can see, it says that this is, by the way, my account admin requested this model to go from non-status to staging status. And you can see that when I wanted to do retraining and test my retraining code, AutoML created another model, version 3, and I did the same thing. I tested, and even for the same third model, I was able to push it for production and do A/B testing, which I'm going to show you quickly. So how I enabled, by the way, webhook in Slack? Well, I have a dedicated video on how you can use webhook with MLFlow and enable it in Slack. I want to add that video to the video description. So check that out, the video description of this video that you're watching, and you can see the link that how you can enable this webhook in Slack channel through MLFlow. I told you that now the request has been created, the webhook gonna do two things. First was the Slack channel, and second, it's gonna test the model before approving it to go to staging. It should trigger a job for me. And I told you this demo already created a job for me. So if I go to the workflow, you can see that there you go, staging validation. This is the job that this demo created for me, and you can see it got succeeded. That's why my model was able to go to staging. But what is that code and what are the tests that it is doing? This is actually the code, the 5th notebook from this demo, or sorry, the notebook number 5. So we are here, and someone has requested the model to go to staging, and this is the job, or this is the code of the job that we are running through webhook. So what we are doing here, this job gonna know, okay, which model you're testing and what model version you're testing. Webhook will give these informations to this job, so this job gonna know which model should be tested. After getting that and getting the run information for the best model, we're gonna validate this. So it's gonna load the model as a Spark UDF, so we can distribute the predictions, and it will test the model to make sure it can do some predictions or not. So let's give it a try. If it fails, it says, well, this model cannot predict because features are not incompatible or for any reason. And I saw that, well, it got successfully worked, so it passed. Signature check. This is optional, but it's worth when you're registering your model. Specify a signature. What does signature mean? Signature says what is the schema of model input and what are the schema of model output. What are the input column types and features, and what are the outputs. That's it. We already specified that, and this code is just checking to make sure that we have a schema in place or not. So if it's not, it gonna says that this is a missing, you're missing a signature, and my test gonna get failed, and my request gonna get cancelled. If not, then that's okay. We're gonna pass to another test, which is demographic accuracy. So what does that mean? This test code gonna check the performance of the model for specific demographic selections. For example, for specific customers, for specific locations of the customer, whatever, check out the accuracy, for example. If it's more than this, then the test gonna get passed. Again, this is just an example. It's not a must to have, and for each machine learning use case, you will have your own sort of test based on this is regression, classification. If you have a specific business requirements, you might don't even care about accuracy. Maybe there is another metric which is important for your business. So use it as an example. Description check. You're gonna make sure, maybe that's a good practice, that your data scientist provided description when they register the model as well. So this is from MLFlow. It is checking that if the model has description or not. If it has it, you're good to go. If not, it says your description is missed or too basic. Sorry, please resubmit it. For example, the number of the characters were low. Artifact check. You're gonna make sure that the model is stored alongside some supplemental artifacts. For example, a picture of RC curve should be also logged, any sort of artifact. So this code is downloading the artifacts and checking the directory of the downloaded artifacts. If there's anything there, you're good to go. If not, it's gonna say you that there is no artifact you logged with this model. So you're gonna fail the request of moving your model to transition. And then this is the end of the results of the test. Does your model has an artifact? Yes, that means 1. It has description? Yes. Has signature? Yes. It can predict and works? Yes. Then what will happen it will, let's say, send them a Slack channel message that, okay, your registered model got approved, for example, or we can say that it got approved to go to staging, and these are the test results that you can send it to Slack channel. And then if your transition got accepted, the transition gonna start and go to staging. If any of those fail, or if there is 0 in any of these tests, then it says that your transition got rejected, and you have to sort of come up with a new request with updates, assuming that we got accepted, which Axel did. And by the way, we are not going to manually run this code. This code is a job that the webhook gonna run it when my data scientist requested this. And then that's it. I saw that my model was in staging. If I go to my models, I saw that it was actually version 2 before, but now it's version 3, got accepted to staging. And there you go. You can see that first I requested, and then with webhook and passing all the tests, it moved to staging. So what is next? Now we're gonna test the model in a staging environment before we move it to production. So what is the test? Let's say we're gonna do some batch prediction. This is notebook number 6 from this demo. Let's do first batch, and then we will do real time. Well, for doing batch, we can use PySpark UDF to distribute the predictions, or manually load the model and do, let's say, pandas prediction if the data is small, right? So we can load the model with Spark UDF using MLFlow with the given model URI, and then with having the loaded features from, let's say, feature store, or we can even get the metadata and input names from the model features. Then we can call feature store and say that give me the features that this model need to do the prediction. And you can see that I'm not doing some merging stuff transformation, because we are calling from feature store. We are all good that feature store knows what columns should be merged together and give me the final input that is needed for my predictions. And you can see it works properly, and my batch prediction gave the charm prediction for each customer. We can write the data back to Delta Lake so we can be used for, let's say, dashboarding. Now for real time, you can do it through UI as well, and even through code. So I can show you how I did through UI. If you go to the models, and let's say this is the model that you want to deploy, you can just say use model for inferencing. It says if you want to do it real time, if you want to stream, or if you want to do batch. So for mine was real time. This is the latest model version I'm going to create. You gave it a name to your endpoint, let's say MG, and you can have maximum 4 concurrent requests to do real-time prediction, or 16 or 64. I think I chose 4 for my endpoint, and that's it. I click on create, and it created this for me. I went to the serving, and there you go. MG got created. If I click on it, you can see I created version 2 at the beginning, and 100% of my requests were coming to version 2 to do the prediction. But I tested retraining that comes with this demo, which is the latest step I'm going to show you quickly. I came up with version 3 automatically after approving my request to staging, and I dedicated 20% of the traffic to this third one, and I'm still using the older version to dynamically change it later 100% to the new one, and then gradually make it to 0 to make sure I'm not making any interruption for prediction. So dynamic allocation of traffic is supported with endpoint of Databricks, and cool thing here is I can have some metrics related to my real-time endpoint, like latency, request rate, so on and so forth. I don't think I have used that model that much. That's why I'm not having any specific logs. So coming back to my workspace, now we know that how we do batch prediction real time. Let's say we have tested batch and real time, and we're good to go for going to production. Now this demo didn't give me a notebook to go to production, because this is exactly like a staging. Now I need to send a request from staging to production. Again, another message goes to my Slack channel, and it will run, for example, another job if it's needed. For example, that batch and real-time test we did, it could be a job that do automatically, and if it get approved, then it will go to production. So because the pattern is the same and the logic is the same, the webhook job the same, so if you see a staging and you know how it works as of now, which I hope so, the same thing gonna be for production. because staging is just an environment like production that we're gonna test the model behave like production, so the same thing. And then retraining. Okay, what this demo is providing us for retraining, it is giving us a code that call AutoML based on a schedule, let's say monthly. You know that in Databricks you can schedule a notebook to run as a job per month, per any schedule. So here this code which calls AutoML will be run monthly to update my best model, and then do the same stuff to have the model in staging and create my real-time or batch prediction. How? It is loading the updated features to train my model and call AutoML to do classification with the features coming from feature store. This is what we're going to predict, and this is the directory of the data, and timeout, which is optional. And again, now this time you see, for example, my accuracy is a bit different with the updated data, and we're going to register the best model, and then we're going to add some description for the model that we're going to register, and now we're gonna transition to staging. That's why in my Slack channel I had now the third version that got requested to go to staging, and again my job that test the model will got automatically triggered again. It got succeeded, and that's why my third version of my model went to staging, and version 2 got archived. So if I show you that, you see that version 2 was the one that I tested initially, got archived, and now the third version from the auto retraining notebook get replaced, approved, and it goes to staging, and I was able to deploy it. So moving back to my retrained notebook, and that's it. So now let's see what we did. We did some featureization. We stored the data in feature store. We call AutoML to train a model. Then we registered the best model. We requested the model to go to staging. And because of that request, my webhook sent a Slack channel message and also triggered a job notebook to test my model. Not the model necessarily, but yeah, testing the model performance, making sure that we have artifacts and stuff. And if that job got run successfully, then my model got approved to go to staging. And when we were in staging, we tried batch inferencing prediction stuff that now we can, let's say, go to production. And I think also this demo is giving you this dashboard, but you need to go to, I think, to SQL. Yes, in the dashboard you can see that. Let me double check. Yeah, it will give you also a dashboard that use those predictions to show you, okay, how the business team can use your predictions as a dashboard visualized. Not sure why it's not loading for me, but this is basically what you're gonna see as an example, which was shown here. There you go. Now you might question, okay, where is CI/CD, my DevOps, my repository? You're right, that was again a demo to enable you and give you the mindset of MLOps and capabilities in Databricks. But what we did, our training code, testing code, transition request stuff, everything was done in one Databricks workspace. But in real scenario, this is not the case. If I'm a data scientist and I have this Databricks workspace, I can just use it for training my code and running AutoML. Then what I need to do, if I want to request transitioning my model to staging, I also have to push my codes to my repo. Like I have a complete video of MLOps with MLFlow and GitHub action. I will add that video, this link as well, to the video description of this video. Check that out. In that video, I'm totally explaining how you can use GitHub repo, create your GitHub action for CI/CD pipelines, move the codes from one workspace to another, and then do the testing stuff. So you can do the same thing that we did in this demo, but if you push the codes to the repository, then your codes will be pushed to another workspace to, let's say, run the staging test that we did to check the model performance and stuff, instead of having them in one workspace to make sure my data scientists are not affecting the job that are performing testing and stuff. And in that video, that is a complete video of MLOps. I have already created multiple workspaces, dev, staging, prod. I have another workspace for model registry, feature store. So check that video out. But again, here, it was a demo, got released recently, and I think it's a good start. That's why I wanted to make sure you're aware of it and you certainly leverage it because it's very easy to implement in your own environment. Hope you enjoyed the video. Don't forget to put your comments if you have any, and if you like the video, I would be happy if you like it. Thank you. Future belongs to people who believe in beauty of their dreams. So dream big, my friends, believe in yourself and take action. Until next video, see you later.